Nitinol is an alloy made of nickel and titanium with a capacity to change shape and then change back again. This shape-changing behaviour sets it in a special class of man-made materials known as shape memory alloys. If nitinol wire is given a certain shape, it remembers that shape. It can be twisted or deformed into new shapes at lower temperatures, but if it is reheated to its remembering temperature, it will quickly recover its remembered shape. These shape memory behaviours result from temperature-induced changes to its crystal structures at the atomic level. Nitinol occupies a niche of its own among shape memory alloys as an engineering material. It mimics human tendons and human hair and has many applications in orthodontics, optometry, electronics and medical surgery. It is also valued by artists for its sculptural and kinetic qualities. In this experiment, we demonstrate how we can manipulate the crystal structures in some man-made materials to influence their behaviours. The experiment will be conducted in 3 parts to explore the properties of nitinol and show how it can be programmed at certain temperatures to remember a shape. This is a very simple experiment to do. We need only a few items of equipment, approximately 10 centimetres of each of the following wires: nitinol, copper, and a steel paperclip, a set of tongs or pliers, a 1 litre beaker, a Bunsen burner, lighter or matches, hot water, a hairdresser's dummy head wired with nitinol as shown, a hairdryer. This experiment is about shape memory alloys, and this is a shape memory alloy known as nitinol, which is made from nickel and titanium. In part 1 of the experiment, we will use 3 different metals: the nitinol wire, a steel paperclip, and copper wire. We will bend the 3 straight wires at room temperature, so each wire is similarly shaped. Our 3 metal wires all now have a V shape. We want to know which, if any of these materials, will return to its original shape. So first we drop in our paperclip. As you can see, the shape we've bent into it is still the same in the hot water. We'll now drop in the copper wire. It too has kept its new V shape. Now let's try the nitinol wire. We have to be very careful when it goes into the hot water because it will change shape quickly. As you can see, the nitinol wire has recovered its original straight shape. We've just observed how differently nitinol behaves from the other metals in identical conditions in controlled temperatures. The 2 common metals retained their assigned new shape, but nitinol appeared to remember and recover its original shape. Let's run that memory test again. This time we will use a hairdryer. Meet Dolly, our nitinol model. She's just had her hair done. These are nitinol curls, of course, but clearly Dolly doesn't need a perm, or does she? Watch what happens when we pass hot air over these curls. Well, so much for the nitinol perm. We've just seen the same behaviour. The nitinol hair remembered its pre-programmed shape, and with a little encouragement from our hair salon and the right temperature, it just snapped back straight again. Part 3 will take our experiment further. You will see how simple it is to give a shape memory alloy like nitinol a new shape it will remember by setting that shape as a memory at a high temperature. In the first part of this experiment, we used nitinol wire with a pre-programmed shape. That is, a straight shape that had been built into its memory. We deformed it at room temperature, but at a certain temperature, known as the transition temperature, it sprang back to its programmed shape. How did we do that? In this final part of the experiment, we show you. This time we bend the nitinol wire into another shape, say roughly a loop. Then we place the wire loop in the Bunsen burner flame. We can see the wire heating. What we can't see is the crystal structure changing. This is what gives nitinol a new memory. We are reprogramming its structural behaviour at a specific temperature so the nitinol atoms remember this shape. We'll allow the wire to cool down, then we'll straighten it out. It's pretty much straight. Watch what happens now when we drop it into hot water. Look, we have our loop back. That's how easy it is. Our nitinol wire has a new memory. From here on, it's a loop.